Okay, so we're looking here at this physics classroom task, Newton's Laws 4. It's important to say as you're doing this, you should always have your notes out. You should be writing down and showing equations and be drawing pictures. This helps big time. I'm going to just kind of quickly go through some of these and not really do the calculations, but let you know. On this first one, several of these are using the exact same equation. So like this first one, you would use the equation F net equals m times a. It's giving you acceleration. It's giving you mass. So you have these two, and you're just solving for net force. This would be the exact same thing on the second one. Same equation. In this case, it's giving you mass. It's giving you net force, and you've got to solve for acceleration. So you have this, and you have to solve for the third unknown. This third question, a little trickier, something we got to think through here, but again, it's the same equation. That's where you have to think about if it's a constant velocity, what is the acceleration equal? It's actually an acceleration of 0. So you'll have to figure this out, but what would the net force need to be to take a mass, 6.5, and then multiply times 0, what would that net force be? This one's one of those situations where you definitely want to be drawing pictures and labeling this, but effectively, over here it's giving you details. Force of gravity, 21.2 newtons. Force normal, 21.2 newtons. The applied force is 16.6 newtons. Force of friction, 7.5 newtons. Excuse me for that. So we come around here, and it says determine the net force. Well, here you're going to be, and it wants a negative value if it's leftward. So what you're really looking at here is you're thinking about these two forces. You can see this is bigger, so if you take this, 16.6 minus 7.5, you would find that the net force would be 9.1. Really, the way you could do this is you can just find net force. Another way of saying that is that the net force, if you want to just do it algebraically, net force is actually by definition the sum of the forces. And so if you called to the right positive and you called to the left negative, you effectively would have been doing this as well. So you can do it a couple of different ways there. This net force would be 9.1 to the right, which would be positive. And then at this point, you can use this equation. You have the mass, and you have the net force to solve for acceleration, which is what it's asking. Okay, and here we're at this final one. This is one that I see a lot of questions on. It gives you individual forces. It says that gravity, force of gravity, and force normal are both 24.4. And then it tells you the force of tension is 40.2 newtons. Friction is 11.1 newtons. It wants to know the net force. That's something we already did before, and I'm not going to repeat that. But then it says the mass of the object, and this is where a lot of folks get stopped up. Bear in mind, since we know force normal and force of gravity, since we have force of gravity and we know what that force is, that we basically can solve for math using this equation. We know force of gravity equals mass times g, acceleration due to gravity, which is 9.8. So if we substitute in everything we know, 24.4, which is that force of gravity, is equal to mass times 9.8. So of course you can just divide both sides by 9.8 to get, or whatever, your numbers will be different, but G will always be 9.8 to solve for that force of gravity. Thank you. I hope this helps. Like and subscribe.